All right, guys, this video is just in case I have to miss today, Friday, April 12th. So our last lesson for Unit 5, Topic 3, which is confidence intervals with means, is about two sample confidence intervals with means. So a couple days ago, we calculated a confidence interval in our calculator to estimate the population mean of handspan of students in statistic classes. So what we're going to do now is actually break it down by males and females. So we would make a decision first to talk about how we're going to compare them or think about if there's a difference or not. But that's all we're trying to see is there a difference between male and female students? But traditionally, just biologically speaking, male students will very likely have a higher measurement just because of height and all of that. So we could say no. Males most likely have larger hand spans. Not saying that that's always going to happen, but we're thinking most likely that will happen. Once again, the whole point of this is just to see if there's a difference or not. Technically, we will be able to tell which one's bigger based off where the interval lies, but we're just going to see is there a difference. So we have our class set of data. For the sake of this video, I'm just going to use my fourth period data just because that was the first one that I pulled out of my little bin. And they were separated into male and female students. So you can see we have male and female students here. And we're going to compute a 90% confidence interval. So 90% confidence interval for the difference in mean handspan of male and female students in statistic classes. But the key is we're going to talk about the difference in between them. So remember, to check the conditions, you have to make sure that both samples are randomly selected and that both distributions are approximately normal. What's really nice about the two sample problems is instead of making you check that twice for both samples, the males and then the females, we will always let you assume that the conditions have been met. And we pretty much always say that in the problem too, so you know. So to calculate this, to do your calculations, it is going to be a different calculator function. It is not going to be number 8 for t interval. It's going to be a 2 sample t interval, right? So it should kind of make sense because now you have 2 samples. Well, first we need to type in the data. In this case, we are separating them by males and females. When we did this a couple days ago, I had you type all of this data into one column. But now when we go to stat edit, I'm going to type the males into L1. So I'm going to type my males into L1. And then I'm going to type my females into L2. So let's get all the females on there. That's the last one. I'm just going to make sure I type all of this in correctly. Okay, so type males into L1 and females into L2. So now to calculate the confidence interval for your calculation, your 2 sample confidence interval, we are going to still go to stat, just below delete, so stat test, but instead of going to number 8, which stands for t interval, that's based off of 1 sample problem. We're going to go down to number 0, which says 2 sample t interval. Remember, you're not going to pick number 9. A 2 sample z interval, that's based off a z-score. Okay, we don't have z-scores with means. Means we use t-scores. So I'm going to select number 0. I have the data. I typed the list L1 into L2. The confidence level we're calculating at is 90%. So I'm going to change that to 0.9. You're going to see this pooled in this unit and next unit. When it says pooled, just always leave it no. We'll never change that. So just leave it what it defaults, just ignore that and hit calculate. So I get a confidence interval of 1.019 to 1.994. So we can then make a comment about this. We can say I am, or we are, in this case, 90% confident that the difference in the population means. This is super important for your test on Wednesday. You have to make sure that you say the difference in population means, because that's what this confidence interval is finding. It's not finding the mean handspan. It's finding the difference in the population means of the handspan of male and female students. So the means of, so I'm just going to copy this down, handspan of male and female students in statistics classes. And then is between, so we have 1.019, and that day we measured our handspan in inches, and 1.994 inches. So that should make sense that those two numbers do not literally represent how far your hand can span, right? That's not going to be 1 inch. We're not little kids here, little babies. But this is talking about the difference between males and females. So that's why we're always going to ask you an extra question with these problems and ask you to actually interpret your findings. We're pretty much trying to interpret, is there an actual difference or not? And to do that, you're always looking at whether or not 0 is a reasonable value. So remember, to tell if a value is reasonable, to tell if a value is reasonable in a confidence interval, it has to be inside the confidence interval. But in this case, since 0 is not within the confidence interval, so since 0 is not within the confidence interval, it is not a reasonable value. And then you need to tell what that means. So if it's not a reasonable value, then we're going to say that we have enough evidence to say that there's actually a difference, right? If it's not a reasonable value, that means there has to be some sort of difference. So there is sufficient evidence to suggest that there is a difference between handspans of male and female students in statistics classes. Technically, on top of this, you could even tell me which one's larger, right? So since we typed in males first and the whole thing is positive, that means male minus female was positive, which means males actually did have the larger handspan. We can ask you that. You saw that on your quiz. You'll see it sometimes in your homework, like which one's larger. Since it's all positive, the first one you typed in has to be the bigger one. So males are in fact larger, but we were just trying to see if there's a difference or not. So we're going to do one more example for this lesson, and I'll do the next video because we're about to run out of time for this video. So let's do one more example to pull this all together.